Good afternoon to each and everyone watching this video right now. This is Aditi Rai from Team Forge and we will be discussing about mind mapping of forging process briefly with my team members Deblina Chakravarti, Deban Shahu, Akanksha Sahu, Ranjit Behra, Aslesha Shukla, Ravikant Kumar. Forging process are of four types: open die forging, closed die forging, cold forging and roll forging. First of all, we are going to discuss about open die forging. Open die forging is also known as smith forging. In open die forging, a hammer strikes and deforms the workpiece, which is placed on a stationary anvil. Open die forging gets its name from the fact that the dies do not enclose the workpiece, allowing the flow of expected contact with the dies. The operator needs to position the workpiece to get the desired shape. The dies are usually flat in shape, but some have a special shaped surface for specialized operation. For example, a die may have round, concave, convex surface or be a tool to form holes or be cut-off tools. It allows rough and finishing shaping of metal, most commonly steels and steel alloys. It allows the forging of very large pieces, in some cases weighing many tons and having greater length and width. Over to Aslesha.
Thank you, Aditi. Now let's talk about properties of open die forging. The process of open die forging serves many purposes besides simply shaping the metal. Forging of the metal align and refines the grain of the metal, which increase strength as well as reducing properties, which is the presence of any air bubbles, even though too small to be seen with the naked eye. It also improves the ability of metal to respond to machining. Forged metal parts have improved wear resistance and other mechanical properties over or similar machine or cast parts. Now it's over to Devans.
Thank you, Aslesha. So the next is how these are manufactured. Open die forgings can be worked into shapes which include discs, hubs, blocks, shafts, sleeves, cylinders, flats, hexes, rounds, plates, and some more custom shapes. So, what are the advantages? So, there are reduced chance of the voids, better fatigue resistance, improved microstructure, continuous grain flow, thinner grain size, and of greater length. So, next I request Deblina to carry forward the session.
Yes, so next the closed die forging. So basically the closed die forging can be grouped up as upset forging and drop forging. So move to the next slide. Yes, so in drop forging, the dies contain a profile of the desired part, moves upward each other, and covers the workpiece in the whole. The heated raw material, which is approximately the shape or size of the final forged part, is placed in the bottom of the die. Coming from above, the impact of the top die by the help of mechanical ram on the raw material forms it into the required shape. And in upset forging, the impression of the ram operated heading tool or the punch. The metal bar is heated then while holding it firmly in the special tooling with applying pressure to the end of the bar in the direction of its axis to deform it. The process allows the production of long part with forced end. So next let's move on to the property. So, as the metal flow is restricted by the die contours, this process can yield more complex shapes and closer tolerance than open die forging process. Additional flexibilities in forming both symmetrical and non-symmetrical shape come from the various pre-forming operations, sometimes bending prior to the forging, and Most of the engineering metals and alloys can be forged via conventional closed die process. Among them, the carbon and the alloy steel, tool steels, and stainless, aluminum, and copper alloys, and certain titanium alloys are there. Next, let's move on to the application part. So, it is used in construction machineries like excavator bucket teeth, in the mining industry like ground foundation bits, in the automotive applications like connecting rod, control arms, rock arm, in the agricultural applications such as gears, shafts, spike, etc. So, over to Akanksha.
Thank you, Deblina. Now we are going to learn about working of the cold forging. So, the cold forging manufacturing process is performed at room temperature. The workpiece is squeezed between two dies until it has assumed their shape. To deliver a finished, ready to fit component, the technique includes rolling, drawing, pressing, spinning, extruding, and heading. Cold forging extrusion is one of the most common manufacturing techniques widely used in the production of automotive components. Now, let's move to advantage. Cold forged parts require very little or no finishing work. Since all bars are annealed before being forged, there is no need for a secondary heat treatment prior to machining. Cold forged parts offer a good level of attainable dimensional accuracy and excellent surface quality. The economic advantage combines with high production rates. Now we will learn about application. Cold forgings are very popular with the automobile industry for manufacturing steerings and suspension parts, anti-lock braking systems, axles, baits, clutch hubs, gears, pinions, pins, step and intermediate shaft and sleeves. Now over to Ravikant Kumar.
Thank you, Akansa. Now we are going to discuss about roll forging. First, working. Forging process where the workpiece is fed through two specially shaped rolls to create a long product with varying cross section. Heated workpiece, usually a rod of some form, is fed in between two shaping rollers. The grooves in the rollers allow the part to have a variable cross section optimized for the next operation, which can be machining, thus effectively minimizing the need for material removal before the completion of final details. Now move to applications. Roll forging is often used to produce parts for automotive industry. It is also used to produce things like knives and hand tools. So here is our mind mapping for from Team Forging. Thank you. Please like, subscribe and share.